this object is positively charged and this one has a negative charge. Close together, they attract. That's no surprise. But what if they weren't charged or neutral objects? Could they still attract each other? They actually can. But if you're thinking, that's impossible, let's change perspectives and take a look closer. Follow me through the atomic and molecular world, where negative electrons and positive nucleuses reign. Their charges cancel to zero when they form atoms. Atoms form molecules, and these particles build pretty much everything around us. But even with zero charge, these particles can attract. How? Well, think about this molecule as a school. When the electron students play catch outside, they constantly randomly move around the nucleus campus, keeping overall charge zero. But their random movement can result in more electrons found on one side than the other. This electron-heavy area takes a temporary small or partial negative charge, and the other a positive one. Surrounding molecules get induced into this trend, and since opposite charges attract, the molecules get pulled together. We call these van der Waals forces. Correctly aligned, they pull close neutral surfaces together. That's how geckos climb the walls, and how engineers created these amazing gecko gloves. Whoa! So van der Waals forces allow neutral objects to attract. But guess what? There's another way this can happen, explained by the Casimir effect in the quantum world. And the quantum world is pretty weird. This particle also behaves like a wave, and waves have different wavelengths. Now watch what happens when I place these two boats in this area full of waves. You can see that waves of all wavelengths hit the boats from outside, but only some fit between. More waves means greater force is exerted on the boats from outside than between, so the boats get pushed together. Now let's apply this knowledge to the Casimir effect. If we create what we would think as empty space, a vacuum, removing all matter and reducing energy to minimum, there are still virtual particles and antiparticles that pop in pairs and annihilate out of existence. Now when we place these two neutral metal plates parallel and close together, the plates act as mirrors for virtual photons, virtual particles of light. Virtual photons of all wavelengths bounce off the plates from outside, but only those whose wavelengths fit a whole number of times into the gap bounce between. Like we saw with the boat, more virtual photons means a greater force is exerted on the plates from outside and between, so the plates get pushed together. That's how the Casimir force allows neutral surfaces to attract. But what's the use? Well, ever wondered your computer lighter and faster? Yeah, smaller and more powerful nanochips could be the answer. But at such small scale, the Casimir force attracts the components inside, making these innovations more difficult. So you see, whether we notice it or not, we're surrounded by strange phenomena capable of explaining seemingly absurd ideas. So whatever the situation, if something seems impossible, change perspectives, take a step closer or further, and you'll find a way to make the impossible possible.